let's talk more about reverb in Reaper. So I had you download a couple of different reverbs. You're, of course, welcome to or not. They're encouraged right now. But I wanted to go over some of the differences between them. And before we get going on that, what I want to say is that we're dealing with algorithmic based reverbs, uh, meaning that the reverb is applied artificially from math operations, or rather, typically all pass filters, which again pass all frequencies but change phase relationships, and or a series of delay lines. This means that these reverbs are algorithmically designed as opposed to being replicas or based off of actual spaces or halls. Um, the way that the algorithm is designed is pretty nifty, of course, and much care has been given into creating reverbs that sound like a large concert hall, or a live room in a recording studio, or a plate reverb, which is an entirely different type of physical reverb, analog reverb device. These typically are known under the category of Schroeder reverbs, as he was the one who developed a number of algorithms for these types of reverbs. And that's what we're going to be looking at specifically right now. On the next page and in the next video, we're going to look at convolution reverb, which is a different beast, but produces really amazing sounding results. So just wanted to start off with that. Now let's scoot over to Reaper here. So we've got our sound, same sound as last week. Oh, whoops, I need to change my output here. Oh no, it's good. Let's sorry. Okay, sorry, I had something down from the last video. Just need to fix it. So again, same countdown video of our TA, rather jumbled mess of numbers.
5, 7.
It's gonna work great though. So let's first pull up the Reaper reverb again, and there are two of them. There's this reverb and reverbate. Reverb requires that you create your own set of signal chain. I think this is a little bit complicated to use for someone new to this. So I would suggest you not use reverb, but instead use reverbate if you're staying in the Reaper ecosystem. And again, to hear this, it sounds like this.
5, 7, 2.
Oh, haha, I put it on the wrong track. Oh, this video's off to a bad start. Okay, there we go. Let's try it now.
5.
Perfect. All right, let's open it back up. Here we go.
5.
Again, if we change the room size.
7, 2.
Great. Stereo width is going to affect how wide this reverb sounds.
8, 5, 7, 2, 8, 5.
Now we have a mono reverb if it's set to 0. Our initial delay sets how long that initial time between the direct sound or the dry signal and when we hear the processed sound.
5.
And then a reverb is always going to include a low pass and a high pass.
7.
Many spaces, as they absorb sound as it bounces around, are actually going to filter out frequencies in different ways. And it might be desirable to place a low pass or high pass on our reverb
2.
so as to change the quality and timbral characteristics of that reverb.
8.
We'll talk about some of those in a later class when we get into mixing in a lot greater detail. So this is the Cocos Reverb 8. And to turn this on and off, we can use our Shift key. We'll activate it or unactivate it. Same thing as pressing the check mark here. So turn that off. I'm going to add another reverb. Let's add next the M charm verb. And what we're also going to do for the moment is we're going to open up our FX window, which will allow us to see these within the FX window. And now we can switch between them and we can more easily turn them on and off here as well. So just like the last one, I'm going to set my dry-wet ratio all the way to wet, just so that we're hearing the reverb itself at the moment.
5, 7.
And notice we have both a size and length parameter for this reverb.
5, 7, 2,
Sorry, I had to cough for a second. So keep going.
5, 7.
So the size and length in the M charm reverb actually work together. The size dictates the delay times between the reverberating reflections. And the length is going to set the resonance, or rather not resonant, but reflective qualities of these surfaces within our resonant or reverberant space. So if we max them out, size 100%, length 60,000 milliseconds. If we have a short length but a high size,
8, 5, 7, 2, 8.
and again, if we reduce the size here,
8, 5, 7.
this is a very small sounding space
2.
now. Even in a very small sounding space, we can have a long length.
8, 5.
And it makes it now sound quite resonant, still small. So it's a really interesting, different sounding reverb. We can pull up presets here by pressing this button of 9 boxes together. And this has a number of presets for us. Let's look at master here first. We'll do lively marble.
7, 2,
We try a different one.
8, 5, 7, 2, 8, 5, 7, 2, 8.
Great. It's got its own quality. Let's look at a different reverb now. So I'll bypass or make this one unactive, add a new reverb, and I have a couple that you will not. Some of them are paid for. But let's open up this Yuhi. Let's first grab the Tal Reverb 4, and I'm going to grab the VST3 version, add that in.
Then,
And again, just so that we're comparing apples to apples, I'm going to go dry 0, wet 100. pull my size down so we can hear what it sounds like.
Then 2,
Or size all the way up.
8.
We can clear it out by knocking the size back down. So in this case, the diffuse setting sounds like it's saying how are the different frequencies and reverbs diffused in space, or essentially refracted, could be another way to think about it. Are they kept as parallel waveforms, or as they hit a surface, do they go in all kinds of wacky directions, causing our reverb to spread out in the stereo field? And this delay is not labeled appropriately, but this is actually our pre-delay. So if we add in our dry signal,
Then 2.
you can hear that affecting the amount. And these modulations are fun to play with. If you're trying to create a artificial sounding space or an effect for sound design purposes, that can be something useful to play with. Again, this reverb, just as the M-Sharp verb does, has a number of presets which can be useful to us. So let's grab dark, big. Again, we'll go dry, 0, wet, 100, just so we can hear what it's sounding like. And that gives us an idea. All right, we'll turn this off. The next one I want to add is the you, he, and we'll do the proto-verb here. Again, we'll just listen to it for a moment. We'll turn dry all the way down, wet all the way up.
Then 2. 8. 8.
If I raise my decay, we'll turn it off for a second. If I bring my decay down,
Then 2. 8. 8. 5.
so what's interesting about the you, he is it's not as explicit in how it's loading and how you can affect it. But if you hit this R&D model button, notice we bring in a different type of reverb model.
Then 2. 8. 8. 5. 7. 2. 8. 8. 5.
And there's also delays associated with this reverb.
5.
And as with all the reverbs, we have a number of presets that we can load in. So let's do deep room. And again, we'll go dry 0, wet 100.
8. 5.
And now we can switch between these.
7. 8. 5. 7. 2. 8. 5. 7.
Now, what I've tried to do here is set up essentially a similar type of length and size for each of these reverbs. Now, there's no way of comparing these apples to apples. They're different algorithms, they're different plugins, and as such, the parameters do not map to the same. So I'm just roughly picking some things that sound similar on a kind of shotgun-based approach here. But what's going to be interesting about this is that I'm going to allow us to listen back to these, and I'll load in actually one other audio sample. I'm sure you've heard this obnoxious audio sample of me saying my name, but I think it works quite well for some of these testing purposes. We'll grab one more track. We'll just throw that onto there, and then we'll bring all of this over. I can grab these and throw them on this. And they should maintain the same settings that they currently have. Mute this top one, and let's just double check that that is true. Yes. Great. And we'll shrink this back up. And when I click Michael Music, we now see that this track is coming to view. And I'm going to grab the fader down just to negative 2 dB or so that we're not clipping. Okay. And we'll make our loop point do this.
Michael. Music. 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 Michael. Music.
So hopefully what's interesting in what you're hearing is that each of these reverbs have their own sound quality to them. Again, these are algorithmic based reverbs in which the reverberation qualities are being programmed in through math. These are not based on real spaces per se. And as such, there's a different characteristic to each of them, and they have different purposes of when they may or may not be useful to you.